Welcome to graphing sine and cosine functions. So we can transform the graphs of sine and cosine by stretching or shrinking the graph vertically and or horizontally. We can also shift the graphs up or down and to the right or left. So we're going to learn some things about changing the graphs of sine and cosine. Right, the first way we can change the graphs is with a change in amplitude. Right, so definition of amplitude of sine and cosine curves. The amplitude of y equals a sine x and y equals a cosine x represents half the distance between the maximum and the minimum values of the function and is given by amplitude is the absolute value of a. Right? So the amplitude is always positive, right? And it goes from the either the minimum to the midway point or the maximum to the midway point, however you want to look at it. And so half the distance from our minimum, which is down here, right, to our maximum, half that distance is the amplitude. And it's super easy to find in the function. Right? So y equals a sine bx or y equals a cosine bx, that coefficient in front of sine and cosine, if it's positive, that's your amplitude. If it's negative, just take the absolute value, and that's your amplitude. So it's really easy to find. No work needed. Right, so here, increasing or decreasing the value of a will vertically stretch or shrink the graph. So that's the answer to the question on the last page. How does change in amplitude affect our graph? It vertically shrinks or stretches our graph. So on the left-hand side, we have y equals sine x, that's the black graph. We have y equals 2 sine x, that's the red graph. And we have y equals 1/2 sine x. So notice that the maximum minimum values for y equals 2 sine x are twice what they are for y equals sine x. We can see that it goes through positive 2 and negative 2, right? We have the point here. Pi halves 2 and 3 pi halves negative 2. Right? So it's vertically stretched. Its y values are now twice as much. Right? Of course, if we're talking about 0, twice 0 is still 0. Right? So the graphs change the height, but they don't change the width. Right? They're still drawn from 0 to 2 pi. You can see just they're vertically stretched. Unless you have your y equals 1/2 cosine x. So notice that one is vertically shrunk. Right? So now we have an amplitude of only 1/2. Right? Our maximum now is only going to a half. So we have pi halves 1/2 and 3 pi halves negative 1/2. Right? So just by having that, changing your a value from 1, it's going to vertically stretch it if it's greater than 1 and shrink if it's less than 1. And so over on the right-hand side, we have y equals cosine x, y equals 2 cosine x, y equals 1/2 cosine x, and we see the same things, right? So the graph of y equals 2 cosine x is vertically stretched. Now its maximums are at 2, minimum at negative 2. For y equals 1/2 cosine x, it's vertically shrunk, right? Its maximum here is now only at, here we have 0, 1/2, so it's only half as much. Right? And here we have the minimum value, it's only half as much. So that's at pi negative 1/2. Right? So vertically shrinks or stretches our graphs depending on the value of a. I believe I have it shown, a greater than 1 vertically stretch, absolute value a less than 1 vertically shrink, but you follow along in your notes. And if anything is up here that's not in your notes, put that in your notes. Try to give you as much as possible. All right, so here we have the values for y equals cosine x. Right? And so I could graph y equals cosine x. Right? It would go through the point 0, 1, pi halves 0, pi negative 1, 3 pi halves 0, and 2 pi 1. All right, so this would be the graph of y equals cosine x, and of course it would just continue and keep doing the same thing over and over and over again. This is just one period of the graph. If I graph y equals 3 cosine x, all of my y values are going to be 3 times as much. Of course, 3 times 0 is still 0. So we can literally just take our y values, multiply them by 3, and we would get the right we would get the right y values for our graph y equals 3 cosine x. All right, so notice the x values didn't change at all, but the y values are going to be 3 times as much. All right, so for y equals 3 cosine x, instead of 0, 1, it goes through 0, 3. Instead of pi halves, well, that one will change. So that will still be 0. Instead of pi negative 1, it's going to be pi negative 3. 3 pi halves won't change. That'll still be 0. And 2 pi will now be at 3. So now you can see our graph has been vertically stretched. It's 3 times as much. Let's talk about range and domain on this one. All right, so we know the range of all of our sine and cosine graphs is all real numbers. The domain of all of our sine and cosine graphs, domain, is going to be all real numbers, both for the blue graph, which is y equals cosine x, as well as the red graph, which is y equals 3 cosine x. But the range is different between the two graphs, and I think that's clear to see. Right? So the range for the red graph is now -3 to 3 instead of the usual. So this is for the blue graph was y equals cosine x. Its domain was -infinity to infinity, just like y equals 3 cosine x, but its range is only -1 to 1. So the amplitude change is going to change your range. Nothing, by the way, changes the domain. As is always true with our graphs that have domains of all real numbers. Here I have one graphed already. I have y equals -2 sine x. The amplitude is 2, stretched by a factor of 2. The negative is going to reflect across the x-axis. Right? Oh, and I think I had this one for you to graph, perhaps. I don't have the notes in front of me. So just make sure you add in the things you need to. And I don't remember if I have this one for you to graph or if it's already graphed for you, or if I didn't include it. But for y equals -2 cosine x, the amplitude is still going to be 2. It's just reflected. So the black graph is y equals sine x. The red graph is y equals -sine x. Right? And all of our y values have been multiplied by -2. Right? So I simply multiplying the normal y values for y equals sine x by -2, you get the graph of y equals -sine x. Here we have y equals -1/3 cosine x. Amplitude is 1/3, and the negative is going to reflect it across the x-axis. It is vertically shrunk. If we take our y values for y equals cosine x and multiply them all by -1/3, we will have the y values for -1/3 cosine x. Right? And then, of course, I'll just do the domain and range for the changed graph, not the base graph. So y equals -2 sine x, domain, of course, all real numbers. Range is going to be -2 to 2. For cosine over here, right? Domain, all real numbers. Range, it's been vertically shrunk. It's only going to go from -1/3 to 1/3. That's it. That's its whole range. All right? Let's continue on. All right, so let's identify the amplitude here from our equations. What's the amplitude of y equals 0.25 cosine x? All right, so the amplitude, if you like it as a decimal, it's 0.25. If you like it as a fraction, it's 1/4. How about the amplitude of y equals -sine x? All right, well, remember that amplitude is the absolute value of that number in front. So our amplitude is the absolute value of -1, which means it's also 1. Right? So it's not vertically stretched or shrunk at all. That graph would just be reflected. And the amplitude for y equals 3 sine 2x, of course, it's right in front there. And here it didn't have anything in front. It's just the 1. But I guess I can underline that part. Right in front. Our amplitude is 3. That's how easy it is to identify the amplitude. It is always the coefficient right in front of sine or cosine. Right? And that will always vertically stretch or shrink our graph, right? Unless the amplitude is 1, in which case it'll stay exactly the same in terms of at least the vertical stretching and shrinking part. All right, so the next important thing to know about trig graphs is period. Right? So the period of a trig function is how long it takes to complete one cycle. We've been graphing one period of the graph. Oops, there's no graphs on that page. So all of these were one period. Right? If I were to repeat the graph further, it would just be repeating what we see right there. So how do you know what's one period? Well, you can solve for one period. Right? And it's really, really easy. All right, so normally, the period for y equals sine x and y equals cosine x is 2 pi. Unless we change our equation up a little bit and it's not just y equals sine x or y equals cosine x. Right, so the period is determined by the coefficient in front of x. Right, so the coefficient in front of x. And what you're going to do with that value is you're going to take 2 pi, the normal period for a trig function, and divide by that value, and that will give you your period. So the period for y equals cosine bx or y equals sine bx, right, is just going to be, in either case, 2 pi divided by that value, whatever b is. Right? Could be a rational number, could be an irrational number. What irrational number could it be? Sometimes it's pi. Right, let us take a look. There we go. So when b is between 0 and 1, the period of the function will be greater than and. Oh, that's a nice sentence. Then y equals, actually, let's put in just 2 pi. 2 pi. It's going to be greater than 2 pi, because that would be the period for sine and cosine. All right, so the period of the function will be greater than 2 pi, and the graph will be a horizontal stretching. All right, so you think about it. If you're dividing 2 by a really small number, it's going to get bigger, right? So if you divide 2 by a half, right? Imagine you got 2 pies and you cut them all in halves. You got 4 pieces, right? It gets bigger. And it's going to stretch the graph out. It takes longer with that coefficient in front of x if it's between 0 and 1. If the value is greater than 1, the period is going to decrease, right? We have a horizontal shrinking, right? Period is shorter. A negative on b reflects across the y-axis, but it doesn't change the period at all, right? It has no impact on period whatsoever. And we'll basically be working with b being a positive number. We won't be reflecting over the y-axis. X-axis maybe, but not the y-axis. All right, so make sure that's in your notes. All right, so when b is greater than 1, the period decreases. We have a horizontal shrinking. When b is between 0 and 1, the period increases. We have a horizontal stretching. All right, let's take a look at identifying period. It's super easy. All right, so here, just to show you though, before we identify it, all right, we have 2 different graphs. Actually, we have 3 graphs on each of these. The black graph is y equals sine x to the left and y equals cosine x to the right. It takes 2 pi for it to go through the cycle. After 2 pi, it'll just do the same thing again and again and again and again. All right? In the red graph is y equals sine 1/2 x. So if we take 2 pi and we divide by 1/2, That's the same, I have below there, is 2 pi times 2. So that gives us 4 pi. So notice it's horizontally stretched. It takes longer to go through the period, through the cycle, before it repeats. Then we have, and then likewise, we have on the right-hand side, we have y equals 1/2, y equals cosine 1/2 x. Its period is also 4 pi. Right? This graph only shows 2 pi. We didn't even get the end of that graph before it repeats. So the red graph hasn't even gone through the cycle on this graph. And the blue graph, well, it's gone through the cycle twice. The black graph has gone through it once. So in 2 pi, the red graph has gone through half a cycle. The black graph has gone through 1 cycle. And the blue graph, he's a busybody. He went through 2 cycles already. So y equals sine 2x. The period would be 2 pi divided by 2, and it would be pi. So it would be doing everything twice as fast. Right? So it doesn't change your range at all, doesn't vertically stretch it at all, but it does horizontally stretch it, and it makes it go through the cycle faster. Or I should say stretch or shrink, depending. All right, so y equals cosine x completes 1 cycle in 2 pi. All right, so this is 1 cycle of the graph right here, from here to here, right? That's 1 cycle, right? That would be 2 periods. Y equals cosine 2x completes 2 cycles in 2 pi. All right, so here would be 1 cycle of the graph. All right, so by the same time as y equals cosine x completes the cycle, it's already gone through it twice. And then y equals cosine 1/2 x completes half a cycle in 2 pi. So the period is 4 pi. Right? So here would be, I don't know what the little black lines are. I have a feeling they once were supposed to be here. And it doesn't quite make it on this graph. Well, almost. They cut it off before 4 pi. It's about right there. It should hit it, right? So now it takes 4 times as, or I should say it takes twice as long for y equals cosine 1/2 x to complete 1 cycle as it does y equals cosine x, and it takes 4 times as long as y equals cosine 2x. Right? That's gone through 2 cycles already. All right, so hope you're starting to understand the difference between amplitude and period and how we calculate those out. And we're going to do a little bit more work with identifying period. So which graph has the shortest period? Well, don't necessarily look at the graphs because they are not to the same scale, right? So if you notice here, one of them is going by pi, one of them is going by pi halves, right? You can't really tell just by looking at the graph. We're going to calculate out the period for all of these. I do have 1 period shown on the graph so you can see what it looks like. Right? So our first one, the blue there, shows 1 period of the sine graph because sine is going to start at 0, 0. Right? And then it gets its maximum, x-intercept, minimum, comes back again. Right? That's what y equals sine x does. All right, so let's find the period here for number 1. All right, so the period is going to be 2 pi divided by b. All right, so b is the coefficient, right there it is, in front of x. Right, so b is 2. So we just take 2 pi and divide by 2. And the period is pi, so it goes through the cycle in pi. And you can kind of see that because, do you see the pi right there? Pi right there? So it went through the cycle in pi. All right, so now let's take a look at number 2. Y equals 2 cosine 3x. Right, got a little bit different scale here. Looks like, maybe pi is the same amount on both of these. But let's calculate out its period and find out how long its period is. Right, so the b there right in front of x. Right, so b is 3. So we have 2 pi divided by 3. Right, so there's nothing else to do with that. It doesn't reduce. We have 2 pi thirds. Well, 2 pi thirds is shorter than pi. So right now, number 2 is winning the race. Let's look at y equals 5 halves cosine x over 2. All right, so our b is under the x there. That x over 2, that's the same as 1/2. So b there is 1/2. Let's find the period. So the period is going to be 2 pi divided by 1/2, which is the same as 2 pi times 2, which is 4 pi. All right, so it takes 4 pi to go through the cycle. And you can kind of see there's 2 pi, and it's only halfway through the cycle. All right, so by the way, when I say cycle and period, it's the exact same thing. I guess I could be consistent and basically the same thing. So I will just put period on all of them. All right, so right now, number 3 is losing the race. Number 2 is winning the race. Let's see about number 4. All right, so b is right there. It's b is 1/3. I'll just put it right here. b is 1/3. All right, so the period is going to be 2 pi divided by 1/3, which is the same as 2 pi times 3, and that's going to be 6 pi. All right, so now number 3 doesn't feel so bad. It's not as slow as number 4. All right, so 6 pi. Number 4 is losing the race. Number 2 is still winning. Number 5, let's find the period. All right, got to be careful here. It's pi thirds. All right, so b here equals pi thirds. And actually, I like to be consistent color-wise with the graph. All right, so you can, by the way, you can see how long a period is on the graph. The graph of 5 makes it look like it has a longer period than number 4, just because the scale is different. So you can't look at these graphs exactly and tell, but we're going to calculate it out because it is super easy. All right, so b here is pi thirds. All right, so we're just going to take, period is just going to be 2 pi divided by pi thirds. Well, that's the same as 2 pi times 3 over pi. All right, so if we're dividing by fraction, it's same as multiplying by the reciprocal. So the pi's are going to cancel, right? And we have 6. Well, what's bigger, 6 or 6 pi? Well, 6 pi is 6 times 3.14. So, and repeating, and so on and so on and so forth. So 6 pi is definitely larger than 6. All right, and now the last one. All right, so right here, pi over 2 is b. So you got to remember to include pi. Pi is not a variable, right? It has a value. It is a constant. So the period is 2 pi divided by pi halves, which is the same as 2 pi times 2 over pi, right? We just multiply by the reciprocal. So the pi's will cancel, and this one is 4. All right, so now let's put them in order from least to greatest. All right, so who was the absolute fastest? All right, so we have 4. Well, that's going to beat 4 pi. It's going to beat 6. It's going to be 6 pi. Does it beat pi? Well, pi is 3.14, so it doesn't beat pi. And 2/3 of pi is less than 1 pi. So the winner on the, we'll list them in order, and then we'll put them shortest and longest. All right, so the shortest, going in order here, was number 2. 2 pi thirds is the shortest period. The second shortest period was number 1. Oops. All right, with pi, followed by number 6 with 4. 4 is larger than pi. And then 4 pi is larger than 12, right? Because 4 times 3 would be 12. So multiplying by 3.14 is going to get a number larger than multiplying by just 3. So number 5 is going to be next at 6. And then we have the last 2, which is number 3 with 4 pi. And the loser in today's race was number 4 at 6 pi. So the shortest period was number 2. Number 2 had the shortest period, and the longest period was number 4. Right, so number 2's was 2 pi thirds, and number 4's was 6 pi. All right, so I hope you enjoyed our little game here. Who wins the race in terms of period? All right, so I hope you enjoyed that one. I think this might be the end of my podcast. Do I have any more? I'll know because, I have this one. This is the end of my podcast. We're going to identify the amplitude and period for each of the functions. And I promise that this podcast will take less than a half an hour. That doesn't sound so good for me. Let's do it really, really fast. So, amplitude, right in front there is 3. The period would be 2 pi divided by 2, because our b here is 2. All right, so that's just going to be pi. Number 2. Right? So amplitude right in front is 1/2. The period is 2 pi divided by b. b is 3. So it's 2 pi thirds. That sounds like one we already had. And finally, amplitude right in front is 2. And the period is 2 pi divided by b. Our b is pi here. So our period is 2. The amplitude and period are both 2. And that's all there is to this lesson here. If you have any questions, let me know. Hope you enjoyed this podcast. Bye for now.